Hi class, in this video we're going to be talking about section 3.1, Numeration Systems. And so we're going to start by talking about the number system that we use every day before we then start transitioning into working with numbers, addition, subtraction, multiplication, division, and particularly we're going to stick with just whole numbers today, but we'll expand to other types of numbers, including fractions, decimals, and so on as we continue through this course. Now, a numeration system is a collection of properties and symbols that are agreed upon to represent numbers systematically. Right? So a lot of mathematics, even though it may seem very natural or for granted, is just often a set of conventions that we've agreed upon. And so the system we use is base 10 because every time we get to a 10 of something, we rebundle to say 100 or 1,000, right, which is 10 tens or 10 100s and so on. But that's not the only way to do it. So number systems are base 10. The clock is base 60 because we get to 60 before we add another 1. And the numbers we use, the 1, the 2, the 3, and so on, are actually Hindu Arabic numerals. And so they were kind of independently emerged or jointly emerged between civilizations in India and the modern day Middle East. And that's the system that we use today. And so those symbols are the 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And so each of these numerals have some properties. The first property they have is face value, the quantity that a numeral represents. So the 1 represents one of something. So in this case, one finger, or say 1 pen. Or a 3, right, represents that we have 3 of these pens. And so the face value is the quantity that a numeral represents. And the association between a number of objects and the numeral we represent it with is called cardinality. So being able to look at this and say there's 2 of these objects, which means that together this is 2, is called cardinality. And so cardinality isn't something that we're born with. We may not remember when we learned it, but it's something that all children learn in their early elementary grades. They learn that if I count 1, 2, 3 objects, this group has 3. Or 1, 2, 3, 4, 5, 6, 7, 8. That together represents the number of objects. And then it's also important that we remember that when we represent a number, say 3 here, this symbol we use, the 3, isn't a natural, already out there symbol. It's something that we've agreed to use. And so we often work with multiple representations. And so think about children have to learn these numbers just like they learn their letters. But they also have to learn that 3, when I hold up 3 fingers, they have to learn that that corresponds to this symbol of 3, which is the same as these 3 dots. Right, and so we have to think about our numeral representation. So this is a numeral. This is our finger. And this is our set representations. And so we have to work between these different representations for numbers and quantities because these are the understandings that children need really as the foundation of our number system. But that's just face value, the quantity that a specific number, or in this case numeral, represents. But we also have place value. Numbers can have a second meaning, and that is based on its location. Say if we have 2, 0, it's not literally just 2 and 0. It's 2 tens and 0 ones. And so often you'll see something that looks like this, which is a place value chart, my brain is like, what's this called? So like if I have this here, 20 is 2 10s and 0 1s, or like 473, while these are still the numerals 4, 7, and 3 in our place value. Each of these has a quantity, or it has another meaning, right? Because it's not just 4 and 7 and 3, it's 4 hundreds, or 7 tens, or 3 ones. Remember I said we call this base 10 because we have 1 10, and once we have, we have ones, and once we have 10 ones, we rebundle into 1 10. And 10 tens we rebundle into 100. And 10 100s we rebundle into 1,000, and so on, and so on, and so on. And of course, it doesn't stop at millions, it keeps going infinitely high. But we call it base 10 because of that. And then you'll start to see over here decimals, but we won't be talking about those for a couple sections. And so place value is one way to start to look at quantity, but we also have these things called number pieces. They're also called base 10 blocks, or Denise was a mathematician and math educator in probably the 50s, maybe the 60s. And he used these when he was working with number with children. So here we have ones that look like this. So this is 5 ones. These are called longs or rods. So longs or rods, depending on what set. Each correspond to a 10. And then this is usually called a flat, which is 1 100. And you see that each of these rods is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 ones. And a flat is 10 of those rods, right? And so again, reinforcing this base 10 idea that 10 ones make a long, 10 longs make a flat. And so in addition to ones, you might hear them called units. So 10 units make a long or a rod, and 10 rods make a flat. And so we can also see these things here are called 5 frames, 10 frames, and 20 frames. In this first one, you see that there are 3 blue and 2 red. And so this gives children a way not to know, right? If this thing is full, it's 5. So you might see something that looks like this. And you might only have 3 of them full, and so you might start to think about, well, that's 3. But when we have the whole thing full, but we have 2 colors, it gets us to start thinking about 2 and 3 are 5, so how we can compose and decompose numbers. And similar to building up in terms of base 10, you would start with these 5 frames really in pre-K to K. And then you might start see 10 frames in kindergarten through first grade, and then particularly first grade for these 20 frames. But it gets you to start thinking, all right, so now I can just look and know that that's 5, 6, 7, 8. Or once I'm familiar with seeing those 10s frames, I can see 10, 11, 12, 13, 14, right? And so we can start to think about numbers in that way. And so really what I want us to, up to this point, is think about there are lots of different representations for quantities. We can have unit blocks, or just a collection of objects and we can count them. We have longs and rods. We have our fingers. We have our 5s, 10s, and 20 frames. We have the numerals themselves, and then those numerals have face value and place value. We also have a number rack, and so they're also called recs. And if you Google these, they're super common, particularly in lower elementary. because these are great for working with addition, for counting, and so you might say, how many are hidden? Well, we can start to make some sort of, we can say, well, here's 10, and so I see 3, 4, 5, so 5 must be hidden. Or you might say, well, these three, let me pick a different color for that. These 3 whites go with those 3 whites. Those 2 reds go with those 2 reds. And so there's 5 left over. Right? Or there are lots and many other ways. And so thinking about this goes back more to the object, so earlier thinking. And I could probably put these in some sort of order. If I had to, I would say number pieces come after 5 frames, which come after number racks. So I would say this is probably the earliest representation after just objects. So let me write that. So thinking about, we have sets, then we have a number rack, and then we have our frames, and then we have our base 10 blocks. Now, and I will, of course, remind you that this isn't the how to teach math to elementary teachers class, but it's really hard to separate those 2 bits of knowledge in my brain, right? So it's hard for me to think about what is a number if I don't think of the representations for number. And then thinking about, well, representations of number are often developed to support students in their learning. And so roughly that's the order in terms of sophistication. And then next would be number line. And so this is even more sophisticated because now I don't have any number of objects. So whether it was my rack or my frames or my base 10 blocks, I still had a concrete number of objects. But now once I get to number lines, I'm looking at the numerals only. And so when I think about if I have 3, I know that that's the distance from 0 to 3 on the number line. Or 8 is from 0 all the way up to 8. And that's 1, 2, 3, 4, 5, 6, 7, 8 jumps of 1 unit. Or I could also take a jump of 3 units and a jump of 5 units. So 3 plus 5, right, gets me to 8. And so thinking about how this now already has a level of sophistication assumed. Because if I'm not counting 1, 2, 3, 4, 5, 6, 7, 8, each of those jumps, I need to be able to see this connection between what a number means. And a number line, while great in terms of thinking about counting on or quantity, is less useful when we want to reinforce place value, right? And so there are times when we want to reinforce numerals and what they mean. There are other times where we want to reinforce place value and the fact that different columns have different amounts. And these representations are each going to lend themselves more or less to each of these goals. Right? If I want to reinforce place value, I'm probably not going to use my hands. Mainly because, I only have 10, and once I get to 10, I don't have like a third hand that I can rebundle on, right? I suppose I could try to use my toes, but as soon as I get to 100, I'm out of luck because I don't have a third thing with 10 digits. And so when we talk about number in this class, I really want us to think about the representations for number. And I think I had started to foreshadow this in an earlier video where what we're going to be doing in this class is I'm not teaching you number for the first time. So maybe some of the sets or truth value items were new. But we're going to start thinking about these quantities in the way that makes sense to think about them as future pre-K through 8 teachers. And so here's an activity that I think is fun because it really gets at thinking about problem solving. So 1.1, but also thinking about numeration systems, our base 10 system, but particularly thinking about base 10 blocks, where we have units, rods, and flats. So this says I have 4 base 10 blocks. Some are rods and some are units. Their value is less than 25. Who am I? So I have 4 blocks. I can have 1 rod and 4 units, right? That would make me 14. I could have 2 rods and 3 ones, which would make me 23. I cannot have 3 rods and 2 units because that's 32, so that's not a possibility. And so we certainly couldn't have 4 and 1 or all 5 because we said that it's some are rods and some are units. Can I have 5 units only? No, because I need rods also. So I either have to be 14 or 23, and I could be either of those. How about this one? I have 8 base 10 blocks. Some are units and some are rods. Their value is an odd number between 50 and 60. Well, I know I need to be at least 50, so I have to have 5 rods, which means I have, could I have 6 rods? Well, if I had a 6th rod, I'd be at 60, and so now I'm too big. So I have 5 rods, and so if I have 8 blocks together, I have 3 left. So they have to be 3 units. And so I have 1, 2, 3, 4, 5, 50 plus 3 is 53. And that is an odd number between 50 and 60. So I am 53. So sometimes you'll have a clue that requires that that will be so specific that you can only be one number. But like in the previous example, I could be either 14 or 23. How about another? And so maybe you'll think about pausing after the question and then see if you can figure out on your own. I have 6 base 10 blocks. Some are rods and some are units. Their value is between 20 and 30. So if I have 2 rods, that's 2 of my 6, I have 4 left. I could be 24. Or can I have 3 rods and 3 units? I could be 36. 1, 2, 3, 4, 1, 2. 42 is too big because I have to be between it. And so those are my only possibilities. Right, you know we can start here because if it's at least 20, there have to be 2 rods. Because if there weren't 2 rods, we wouldn't be at least 20. And there are a couple more of these, and I'll go through them, but again, I encourage you to pause the video after it and really think through what's happening. I have 6 base 10 blocks. Some are flats. Oh, so now we have some flats. Some are rods, and some are units. And I am a palindrome. So what is a palindrome? A palindrome is something that's the same forward and back. So if I say have the number 1, 2, 3, 2, 1, that's a palindrome. Or 4, 5, 4 is a palindrome. Or 7, what is it? A Boeing 747 is a plane. So it's the same both forward and back. So I have 6 blocks. Some are flats, so we can have flats. Some are rods, and some are units. and I'm a palindrome. So that means whatever number I have in flats, I have to have the same number of units. So if I have, let me pick a different color. If I have one flat, I need 1 unit. And if I have 6 total, I have 4 rods, which means my first possibility is 141. If I have 2 flats, I need 2 units. If there's 6 blocks total, I have 2 rods, which makes me 222. Pick a different color. If I have 3 flats and 3 units, well, that's all 6 of my blocks. I would have no rods, but it says some are rods, so I can't be 303. I'm either 141 or 222. I have 2 base 10 blocks. Who am I? Well, it doesn't say how high, so we could either be rods or we could be, let me not start with rods. We could be flats, we could be rods, or we could be units, right? And so I could be 2 units, I could be a unit and a rod, I could be 2 rods, I could be a unit and a flat, I could be a rod and a flat, I could be 2 flats. So I could be 2, 11, 20, 101, 110, or 200. Did I miss any? How do you know? And so this goes back to place value. How do we know all possible combinations? Well, so if I have 2 units, nothing else can happen. If I have 1 unit, I could either have 1 rod, which is here, or 1 flat, which is here. I could also have 2 rods, so I could have 2 units, 2 rods, or 2 flats. And I already had the case where I had a rod and a unit, so here's my case where I have a rod and a flat. And so there's no other possible combination. I have 3 base 10 blocks. None of them are flats. Well, again, thinking about, we have our rods, we have our units. I could either have 3 of both, or 3 of either, rather. I could have 1 unit, which means I have 2 rods. I could have 2 units, which means I have 1 rod. And that, I claim, is all the possibilities. Let's rewrite this. So I have rods, units. I could have 0, 1, 2, or 3 units, right? Because I have 3 blocks. If I have none of these, I have to have 3. If I have 1 here, I have to have 2. If I have 2 here, I need 1. If I have 3 here, I can't have any. And so since I went 0, 1, 2, 3, I know that all possible combinations have been exhausted. And then I just have 2 more of these. I have 4 base 10 blocks. None of them are flats. So again, we have rods and units. I could have 0, 1, 2, 3, or 4. Well, if I have no units, I have to have 4 rods to have 4 blocks. 3, 2, 1, and 0. And then our last one. I have 4 base 10 blocks. Only one of them is a flat. So now we have flat, rod, unit. I have 1 flat, which means I have 3 base 10 blocks to work with. So I could have 3 units, 2 units, 1 unit, or no units. And if I have 3 units, I can't have any rods. If I have 2, I could have 1. If I have 1, I could have 2. And if I have 0, I could have 3. But in every case, I have the flat. And so I am either 103, 112, 121, or 130. So I want you to think about, right, in this section, my main point is thinking about numbers have a face value, a quantity that they represent. They also have a place value. Depending on where they are, they have a different meaning, right? So this 3 in the units and this 3 in the rods have a different place value because this is 3 and this is 30. That's this one and this one. So we have place value versus face value. And there are lots of different representations for numbers. We have our number line, we have our tens frames, we have our blocks, like here we have our base 10 blocks, we have our number rack, we have lots of different representations. We have our fingers, right? I've been counting on my hands as I went. And so there are lots of different representations for numbers, and depending on how we represent them, different things are emphasized. And depending on how we're representing them, a numeral can have different place value. That's this 3 versus 30 distinction. And so I want you to start thinking a little bit. It's hard, I think this is among the hardest things to think back of what is it like not to know a number or the meaning of a number, right? This is one of those things that's really hard for us to imagine. When it comes to like algebra, I can imagine what it's like not to know what a variable is or what to do with a variable. But when it comes to a number, it's really hard for me to think about. And so I want us to start to think really critically about number, because as we move into addition, we're going to start to think really critically about what would it mean not to understand addition? What is the big idea? What's happening behind the scenes? And so cardinality, the idea that quantity is the number of objects in that set, is one of those things that's really crucial. It's probably the single most important thing that we learn in pre-K-8 mathematics. And yet, we probably spend the least amount of time talking about it. And so I really want us to take that away from today's lesson. That number systems, we cannot take for granted. We may not remember when we learned it, but we learned it. It's not something that's innate or naturally inside. And so start to think really critically about what do these things, as we work through things that we've learned, what would it mean for the learner as they're learning it for the first time? Have a great day, everyone.